In order to find the centroid of the area shown in the figure, that is the geometric center of the area, we can start by writing our expression of x bar that is actually derived from the summation of moment expression, and it is given as integral of x prime dA, where x prime is the centroid of the differential area and dA is the value of that differential area divided by integral of dA. Now once we have the formula set, let's figure out our differential element here. So in this case we are picking a vertical differential element having a height of y and the width of dx. Now one point to consider here is to make sure our differential area is touching the curve whose expression is given to us, so that once we move this differential area across and take the integration, we are keeping in account of the changing height as we move along. So in this case, the value of x prime in terms of the coordinate system shown here is equals to x as it is being measured from the origin, whereas the value of dA can be calculated by multiplying the height y times the differential width of dx. Next, let's go ahead and replace the value of y, that is 1 over 4x is squared, so that once we are integrating, all the terms are in the variable x since we are integrating with respect to dx. Once we have both of these values, let's go ahead and plug it in the formula. So our value of x bar is equals to integration x times 1 over 4x squared dx. Now we have to plug in the limits for the integral as well, since the width of the area along the horizontal x-axis is 4 feet. So our limits will be from 0 to 4. Similarly, dividing that thing with the integral of our differential area, simplifying, we can get our constants out, that is 1 over 4 and 1 over 4, and cancel those terms, and then perform the integration on x cubed and x squared. So as you recall, the integration of x cubed will be x raised to power 4 divided by 4. Similarly, integration of x squared will be x raised to power 3 divided by 3. Next, we have to plug in the limits to solve for our x bar. So simplifying and plugging in the upper limits and subtracting the lower limits out of it, we are getting the value of x bar as 3 feet. Now, once we have identified the x coordinate of the centroid of the area, now let's move to the y coordinate. So again, we will be repeating the same process, and this time our formula for y bar is represented at integral y prime dA divided by integral dA again. Now, one thing to make sure is now we are identifying where the centroid of our differential element is present in terms of the coordinate system as represented in the figure. Since it is in the middle of our rectangular area, so the y prime value will be equals to y divided by 2. Similarly, the area is still the same. dA is represented as y times dx. Now again, we want to replace y in terms of the variable x since we will be differentiating with respect to dx here. So our y prime will be equals to 1 over 8x squared, whereas dA is equals to 1 over 4x squared dx. Now let's go ahead and plug these values back into our expression of y bar and solve for the centroid. So our value of y bar is equals to integration 1 over 8x squared times dA, that is 1 over 4x squared dx, divided by integration of dA, that is 1 over 4x squared dx. Again, the limits here are from 0 to 4 as the width along the x-axis is 4 feet. Now we can go ahead and simplify that. 1 over 32 can be cancelled out with 1 over 4. That will give us 1 over 8. Next, again, we have to apply our integration. So the integration of x raised to power 4 with respect to dx is x raised to power 5 divided by 5. Similarly, x square is integrated and become x cubed over 3. Next, let's go ahead and plug in the limits here. So the upper limit is 4 and the lower limit is 0. So we can go ahead and plug these values and simplify it to get our value of y bar, that is coming as 1.2 feet. Now these values of x bar and y bar represent the geometric center of the area. In addition, this geometric center will coincide with the center of gravity or center of mass of the materials that have uniform or homogeneous composition, so that if the density is uniform across the material, then they are going to coincide with one another. Next, let's go ahead and locate that position of centroid on the area itself. Since we have x bar as 3 feet, so horizontally from the origin at 3 feet distance and vertically from the origin at a distance of 1.2 feet, we will have centroid of our area shown as variable c.